All right, Matt 2, here we go. We got lesson 7.2.2, more conditional probability, and this will be day one. We're going to split up this lesson into 2 days. All right, so the first two problems that we're going to do are going to be very similar, and then on day two, we'll do some different types of problems. So in the children's game, Build a Farm, you know, that game, each player first spins a spinner. Half of the spinner's red, half of it's blue. If the spinner lands on red, then the player reaches into a red bag, and if it lands on blue, then they reach into a blue bag. Okay, pretty simple so far. So there's a spinner, half the spinner's red, half is blue. If it's red, reach into red bag, blue, reach in blue. Now the red bag has 10 chicken tokens, 10 pig tokens, and 10 cow tokens. The blue bag has 5 chicken tokens, 4 pig tokens, and 1 cow token. All right, so we want to set up what we were calling a modified two-way table. So first of all, we know that the first thing they're going to do is spin the spinner, and there's two outcomes from that spinner. They can spin and get red, or they can spin and get blue. Both have an equal chance of happening. Red is a 1/2 chance, 50% chance, and blue is a 1/2 chance. So that's where we're going to start with. Now, for the red, you're supposed to dig into the red bag and pull out some kind of token. Now, there's 3 kinds of tokens when you go into the red bag. There are, let's see, chickens, pigs, and cows. So chicken, pig, and cow. Now, in that bag, there's 30 tokens. 10 out of those 30 are chickens, so that's a 1/3 chance of getting a chicken. 10 out of the 30 are pigs, so that's a 1/3 chance. And then 10 of them are cows, so that's a 1/3 chance. So looking at it so far, if we roll red, there's a 1/2 chance of getting red, and there's a 1/3 chance of getting chicken. So 1/3 times 1/2, that gives us a 1/6 chance of getting that one, a 1/6 chance of getting this one, and a 1/6 chance of getting this one. So on this is different from those other two-way tables because we're keeping track of the probabilities and instead of keeping track of like the amount of something happening. So we're not keeping track of there being 10 tokens. We're keeping track of the probabilities of getting each of those tokens. Now the blue bag's slightly different. In the blue bag, there's 5 chickens, 4 pigs, and 1 cow. That's a total of 10 tokens in that bag. So if we happen to roll blue, pig, cow, and chicken are different. Chickens, there's 5, and 5 out of 10 is half. For pigs, it's 4 out of 10, that's 2/5. And for cows, it's 1 out of 10. So the chances of getting blue and chicken are 1/2 times 1/2, 1/4. The chances of getting blue and a pig are 1/2 times 2/5, which would be 2/10, and 2/10 reduces to 1/5. And then 1/2 times 1/10 is 1/20. So these are all of our probabilities in here. 1/6 plus 1/6 and 1/6, and here I've got 1/4, 1/4, and 1/4. Now 1/6 plus 1/6 plus 1/6, that's 3/6. So going across, 3/6 is 1/2, so they're adding up that direction. 1/4, 1/5, and 1/20 together, trust me on this one, is also going to end up being 1/2. So here is all of our probabilities inside of this modified two-way table. Okay, what's the probability of getting a cow on a turn? Well, we've got a 1/6 chance of getting a cow and a 1 in 20 chance of getting a cow. So those are our two probabilities for getting a cow. So since we're not doing it out of like, we're not doing it out of the total possibilities. These are the probabilities of getting a cow. All we have to do is add the two possible parts of where we can get a cow, 1/6 and 1/20. So this would be 1/6 plus 1/20. Now, with all these having a different denominator, you might want to change all of these probabilities so that they have the same denominator, and that'll make it easier to put them together. So let's look at doing that. So what you would do is you'd look at the denominators. The biggest denominator is 20, and you'd ask yourself, do all those numbers go into 20? Well, 4 goes into 20, 5 goes into 20, but 6 doesn't go into 20. Okay, so let's double this. 40. 4 goes into 40, 5 goes into 40, but 6 does not go into 40. Okay, so let's triple it. 60. 4 goes into 60, 5 goes into 60, and 6 goes into 60. So we're going to change all of these to a denominator of 60, just to make them easier to add and subtract from each other. So 1 out of 60 is 10 out of 60, because we multiplied the bottom by 10 and multiplied the top by 10. So that's 10 out of 60, 10 out of 60. Okay, so we're multiplying the bottom by 15. So we multiply the top by 15, that's 15 out of 60. Multiplying the bottom by 12, so the top is going to be 12 out of 60. We're multiplying the bottom by 3, so the top is 3 out of 60. Now it's a little bit easier to work with. We can see now that 1 out of 60 is 10/60ths. 1 out of 6 is 10/60ths. And 1 out of 20 is 3/60ths. So the total probability is 13/60ths. So it's a little bit easier having all of our probabilities with the same denominator. It makes them easy to put them together. What's the probability of getting a chicken? Well, 10 out of 60 and 15 out of 60. And that comes out to 25 out of 60. Now 5 does go into both of those numbers, so I would reduce it and say 5 out of 12. Because 5 goes into 25 5 times, 5 goes into 60 12 times. What's the probability of spinning red and getting a pig? Okay, red and a pig. Here's red and pig. This is the only section where it's red and pig. So I don't have to add two different sections together. It's just a 1 in 6 chance, or 10 in 60 chance. What's the probability of spinning blue or getting a chicken? Okay, so all of these are okay. So or means I'm okay with both of them. I'm okay with spinning blue and I'm okay with getting a chicken. So blue is 15 out of 60, 12 out of 60, 3 out of 60. So 15 out of 60, 12 out of 60, plus 3 out of 60. Now chicken is 10 out of 60 and 15 out of 60. But wait, I've already counted the 15 out of 60. So I don't want to double count that. Because when I looked at blue, blue had this 15 out of 60 part. So I'm just going to add the 10 out of 60. So plus 10 out of 60. So 15 plus 12 is 27, plus 3 is 30, plus 10 is 40. So it's 40 out of 60, which reduces to 2/3. So 66% chance. Okay, what's the probability of getting a cow or a pig? All right, so cows are these two, pigs are these two. I'm okay with one or the other. So I'm going to add up all those. 10 over 60 plus 12 over 60 plus 10 over 60 plus 3 over 60. So I'm doing the 10, the 12, the 10, the 3, and I've got, let's see, 22, 32, 35 out of 60. And 5 goes into both of those, goes in there 7, so it's 7 out of 12. What's the probability of getting cow and a pig? They have to happen at the same time. Cow, pig, they never intersect. They can't happen at the same time. I'm either going to get a cow or a pig, but I can't get a cow and a pig. So that's a 0% chance of happening. Those are actually mutually exclusive from our last lesson. What's the probability of spinning red given that you get a cow? All right, so this means I'm only looking at the cows. So my cows are my denominator. That's 10 out of 60 plus 3 out of 60. Those are the cows that I'm looking at. So my denominator is 13 out of 60. My numerator, I want the reds given that I have a cow. So the red cows are 10 out of 60. Now we can just multiply the top and the bottom by 60, and this reduces to 10 out of 13. So if you already know that you got a cow, what's the probability that you rolled red the first time is what that's saying. So since we have them with the same denominator, that makes this very easy. We can just multiply the top and the bottom by 60 to get rid of those 60s. So it's 10 out of 13. Blue given pig. All right, pig, 10 out of 60, 12 out of 60. So that would be 22 out of 60. And blue, of the pigs, blue is 12 over 60. Again, multiply the top and the bottom by 60, and we're left with 12 over 22. And then 2 goes into both of those, so I end up with 6/11ths. Are red and cow independent? Sorry there. All right, so are being red and being a cow independent? If they are independent, then the probability of red should equal the probability of red given cow. That's the test for independence. We should get the same probability. Well, red's easy. Probability of red is 1/2. Let's see if that's equal to red given cow. All right, red given cow we already found out. That was 10 over 13. So these are not equal, therefore they are not independent. All right, next, name 2 events that are mutually exclusive. We already saw it. Cow and pig are mutually exclusive. Chicken and pig would be exclusive, mutually exclusive. Red and blue would be mutually exclusive. You can't spin the spinner and get both red and blue, so those would be mutually exclusive. So pick any of those. Basically, pick any 2 from the same column or row. So red and blue, mutually exclusive. Chicken, pig, mutually exclusive. I'll just say red and blue. My pen is dying. All right, back page. Where's it at? Here it is. I got to watch the time so that my lights don't turn off on us. Here, I'm going to pause real fast so they don't. All right, we should be safe for the next few minutes. All right, I'm going to change colors since my other color was dying. All right, so at the county fair, there are many popular games to play. One of them is flip to spin or roll. First, the player flips a coin. If it comes up head, the player gets to spin the big wheel, which has 10 equal sections, 3 red, 3 blue, 4 yellow. If the coin comes up tails, the player rolls a cube with 3 red sides, 2 yellow sides, and 1 blue. If the player ends up with blue, then they win a stuffed animal. Oh, good for them. All right, so we are going to flip a coin. There are 2 chances, either heads or tails. Heads has a 1/2 chance of happening. Tails has a 1/2 chance of happening if it's a fair coin. All right, so when we get heads, 3 things can happen. When it comes up, let's see. If heads comes up, we have 3 red, 3 blue, 4 yellow. So we've got red, blue, and yellow. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possibilities. So the red, there's 3 out of 10. The blue, there's 3 out of 10. and the yellow, there are 4 out of 10. We can call that 4 out of 10 or 2 out of 5. All right, so that's if it comes up heads. So our probabilities here, 1/2 times 3/10 ends up being 3/20. 1/2 times 3/10, 3/20. 1/2 times 2/5 ends up being 1/5. It's 2/10, which is 1/5. So 1/5 for that. All right, looking at tails now. With tails, we roll a cube. 3 sides are red, 2 are yellow, 1 is blue. All right, so 3 out of the 6 sides, because we got 1, 2, 3, 4, 5, 6. 3 out of 6, that's 1/2. 2 out of 6, that's 1/3. And then, oops, I did it wrong. Watch it. This is yellow. Ah, see, they put it in a different order. Gotta watch that. Crazy guys. All right, and then blue would be 1 out of 6. All right, so 1/2 times 1/2, that's a 1/4 chance. 1/2 times 1/6, that's a 1/12 chance. 1/2 times 1/3, that's a 1/6 chance. All right, now let's try to get the same denominator just to make it easy on ourselves later on. So 20 is our biggest number. Does 5 go in there? Yep. Does 4? Yep. Does 12? No. No, that's not good. All right, let's move on. What about 40? Does 5 go in there? Yep. Does 4 go in there? Yep. Does 12? No. All right, let's try 60. Does 5 go in there? Yes. 4 goes in there? Yes. And 12 goes in there? Good. And 6 goes in there. So our denominator is going to be 60 again. So we're multiplying by 3, so this must be 9 over 60. And this one would also be 9 over 60. And this one, we're multiplying by 12 to get to 60, so this would be 12 over 60. This one, we're multiplying by 15 to get to 60, so this would be 15 over 60. This one, we're multiplying by 5 to get to 60, so this would be 5 over 60. And this one, we're multiplying by 10 to get to 60, so that's 10 over 60. All right, there's all my probabilities. Let's see if we can answer the problem. What is the probability of winning a stuffed animal? Well, we win a stuffed animal when we get blue. There's a 9 out of 60 chance of getting blue, and there's a 5 out of 60 chance of getting blue. Therefore, we have a 14 out of 60 chance of getting blue, which reduces to 7/30. You can change that into a decimal or a percentage if you want to. Suppose you know that Monique won a stuffed animal. We know she won. What's the probability that she flipped heads? Okay, so we know that she won, which means she got a blue. So what this is saying is, what's the probability of getting heads given we already know that she got blue? Because that's how you get a stuffed animal. Okay, so blue's our denominator. So here's our denominator, 7 out of 30. We already knew that one. Or let's just write it as 14 out of 60 because it's a little bit easier. Okay, of the blue, how many of those are heads? 9 out of 60 are heads. So multiplying the top and the bottom by 60 gives us 9 out of 14. That's our chances that Monique won a stuffed animal. And that is your notes. All right, have a good day. Math hard. See you later. Bye-bye.